All right, what's good, y'all? Link here. I just finished the daily question for today. It was pretty damn hard. I just posted that one. It was like 2 hours of video of me trying to understand combinatorics. So I'm going to try to do an extra problem right now. Last time I finished count special triplets from the weekly concepts 45.4, and now I want to try this one. Maximum products of first and last element of a subsequence. Let's see how this one goes. I'll put this one extra 35, 84. Let's see. Let's import, import this. Okay, let's see. Uh, you're giving you're giving an integer raised nums, okay, and an integer m. Return the maximum product of the first and last elements of any subsequence of m of nums of size m. Okay, so the output is a negative. Oh, is that 81, and the maximum product. Okay, so of subsequence, let's see, subsequence is an array that can be derived from another array by the latest sum or no elements without changing the order. Okay, so it doesn't have to be continuous. Uh, okay, so m is equal to 1. So it would be 9. What? Oh, it's size 1, so I can have the number itself. Okay, okay. So this is gonna be -5 times -4. Okay, okay. Let's see. So the first thing is that I don't think we need to generate all the subsequences, right? Because it's going to be like finite, the number, like the numbers that we can use to form the answer. Um, let's see. This looks like a question I did recently, which was the frequency was like something like related to like frequency. You grab like the maximum frequency of an element, and the frequency had to be odd, and then you get the minimum frequency that's even, and then you subtract those. Maybe we can let's see. Hmm. Oof, let's see. Okay. What I'm thinking here is like in this case, we will grab. Wait a second. Oh, it has to be of size M. Okay, okay. It has to be of size M. Determine the maximum product of the first and last element. Okay, okay. This is not quite then the one that I was thinking about. So in this case, since size is 1, it's gonna be the any the largest or the smallest number in here. In this case, it would be the smallest number to the power of 2 time itself, right? In this case, we have size 3, so this is, let me see, let me grab this in whiteboard. Oh, okay. So in this case, we would have a window of size 3, and then we can just move this window, right? Boom, boom, boom. And then the answer will be 20 because when we get, wait a second, that should be the size 3. The first items of any, oh, any subsequence. Okay, okay, okay. Um, okay, let's see. Oof. Um, uh, so if it's size 3, that means that we need to have 3 minus 2 elements in here, right? So if n is equal to 1, we grab the largest absolute value number that we have here and square the thing. If n is equal to 2, we turn everything to absolute value, and then we grab the 2. Oh, never mind. Okay, so if n is equal to 1, we just grab the largest absolute value number that we have. If n is equal to 2, that means that hmm, if n is equal to 2, which we don't have, oh, we do. Okay, if n is equal to 2, that means that we choose 2 elements that the product will be the largest. In this case, is 7 times 5. Okay, okay. Okay, so it has to be a size. Okay, okay. So what we can do here is we count the elements of size n. Not count. We go over. We make a window of size n. So in this case, we would do is make a window of size 3, right? And then we're gonna grab the first element and the second element. So we started here, right? And then we have the current product is 1 minus and times -5. So this is -5, the current. And then let's see, we can hmm, we can now how are we gonna choose the next window? Because we can keep this window, we can move this window exactly right here. Oh, let's see. Interesting. Um, we must have at least n m minus 2 elements between, right? Okay. So the idea here is like we have I wanted to do. Let's see if 2 pointers will work here. So we have an eye, left, and then we have right, and then the size of this must be 0, 1, 2. So it's going to be 0 r plus left plus 1. That's the window size. In this case, window size is 3, so this one has to be equals to 3. Uh, let's see. What if? Okay, so it has to be size of 3. Uh, oh my gosh, let's see. Uh, it has to be size of 3. So, because in here we can either, so we have left and right. We can, if we move left, then we have to move right. But if we move right, oh, wait a second. No. Oh, wait, let's see. So we have a window right here, and then we check the minimum element. No, we can actually, do I want to track the current product? Hmm. The thing is like the maximum product could be the multiplication of the first element and the last element, right? Oh, it doesn't matter. Okay, so it doesn't matter if we keep moving the right pointer because, oh, okay, so the window has to be, okay, so the window, so we have left, we have right. The window size will be left plus right. Oh, sorry, left. I'm super slow today for some reason. Plus one. This one has to be greater or equal to 3. Yep, has to be greater or equal to 3. It doesn't matter if we have like a window size 4. We can still make the multiplication by choosing 3 elements in that specific window. Okay, so we can start here. This is the what is the minimum we can have here window? It's this one, which is 1 times -5. It's going to be -5. So now we can either, okay, let me actually do the following. Let me actually put the pointers right here. I want to make this. I can make this bigger. So let's make two right here. That's one. And then we have another one here. Okay, so we can have -5. I think we might be able to use sort of like prefix stuff, right? Because we can either, if we can move here and then we can stay with the one here. Oh, no, okay. Yeah, so this is now it's 5. Maybe we don't need to, oops. Maybe we don't need to, we can move both at the same time and keep updating, right? The max, let's see. We have, this is -5. This is going to be 15. But we can also do with, okay, okay, I see now. No, I think I got it. Okay, so as we move the window to the right, we're gonna track two variables, the maximum element and the minimum element, right? And as we move the window, so let's see, oof, so we have one, the minimum, let's say the minimum and the maximum is gonna be the first element. So one and one. Let's have min and let's have max. It's one and one, right? Let me actually use the window itself. Okay. Right here. Okay. As we move here, boom, it moved. So now 5 is the maximum, and the minimum is still 1. And then we update the maximum multiplication, the maximum product we found so far, which is the current right times the current min or the current max. Nope. Oh, it's so before we update. So before we update this, we're gonna multiply. It's gonna be the minimum between the maximum between the best right here, right? We're gonna have best. It's gonna be the max between the right pointer times the minimum and the right pointer times the max. So this is going to be, it was -5, right? Now we go to 5 because it's 5 times 1. I'm wondering if I need to also check for the left pointer. I don't think so because the left pointer will update. Maybe we do need. Okay, you know what? Okay, I got it. So we update using the left pointer. So now the max is not equal to 5. The max equals to 3. And now we multiply. We multiply. So the max, the best will be the max between the best that we already have, and then the right pointer times min and right pointer times max. So this is 15. Go to 15. Move the pointer now. So we don't change the min. We don't change either of them. Boom. Goes right here. Minimum is down -5. So there's going to be -5. And then 3 keeps 3. Now it's going to be 6. So 6 times -5, or 6 times 3, and or 15. 6 times 3 is the best, which is 18. This now goes to 18. Now we move down right here. The max now is going to be 5. And now we're going to multiply -4 times this one is going to be 20. Okay, I think that's going to work. So we have the window fixed. We keep moving. We keep updating the left pointer. And then the best at that specific time will be the max between what we currently have, which is the best, the current element on the right pointer, times the minimum we found so far, and the current element on the right, times the maximum value that we found. So I remember there was a question a while ago that I did, which was like the maximum product, considering that we can have negative numbers. So we must track the smallest number we found so far because that can be negative, and if in the future we find a new negative, then the multiplication between those two um can be the new max, right? So I'm wondering if I need a base case. I think I need a base case because when I say base case, like if m is equal to 1, if m is equal to 2, that's fine. Uh, if m is equal to 1, then we have 0, and then m minus 1, so 0. No, we don't need to, because then we have both at the same pointer, and then multiplication will happen. Okay, I don't think we need a base case. So let's see. We have best is equal to, okay, so let's see. So we have left, right, is equal to 0, and then n minus 1. Let's do n is equal to the length of nums. Okay, as pointer, and then if m is equal to 1, then we're going to be 0, 0. That's fine. So while right is less than length, less than n, we update the left pointer. So we need best min. Let's say, I think we have best. Um, let's do negative infinity, and then we have infinity is equal to 10. Like this. We have current max. That's gonna be negative infinity. We have current min. That's gonna be infinity. So we can update. And then as we go, we update using the left pointer. So best. So let's first update the min and max, right? So current max will be equal to the max of current max, and nums index left. Current min will be equal to the minimum of current min and then nums index left. So we update those two, and then okay, best will be equal to the max of best, and nums index right, right times current min, and nums index right times current max. And at the end, we just return best. This might be, I'm not sure. Let's see. Oh, forgot to update the right pointer. Oops. Right pointer plus equals one. Left pointer plus equals one. There you go. Oh, let's see. That's good. Let's see. I'll give a submit. Maybe that. Ooh, let's go. Okay. Yeah, this is pretty similar to a question that I did a while ago. I'm pretty sure it was from Nico, the bunch of questions that he got. So yeah, I'm glad I was able to do this one at least. Okay, I think that's all I have for this one. Thank you guys for watching, and see you guys next time.